This video describes the features of the transversely mounted Citroën AL4 4-speed automatic transmission. It incorporates electro-hydraulic control for the selection of the gears and torque converter lock-up clutch using Siemens fuzzy logic technology. To suit most driving conditions, the electronic control unit incorporates 9 automatically selected gearshift programs. And for specific situations, sport and snow modes are selectable by separate switches. In addition, when the selector is in position 2, first gear can be engaged for maximum engine braking with this switch. The AL4 automatic transmission comprises 5 main components: torque converter, oil pump, planetary gear train, electro-hydraulically controlled valve body, and the differential, driven by a reduction gear centrally positioned for quietness. The torque converter, which multiplies the torque when moving off, takes the place of a conventional clutch and forms the hydraulic link between the engine and gearbox. Its operation is based on fluid dynamics, and it's filled with pressurized oil. The torque converter consists of 3 components: an impeller driven at engine speed, a shaft-mounted turbine, and a stator, including a one-way freewheel. Basically, it works like this. When the engine is started, centrifugal force causes the oil to flow at high speed from the impeller to the stationary turbine blades, indicated by the fluid in the plastic pipe. Without a stator, the spent oil leaving the turbine would hit the impeller's blades in the opposite direction to engine rotation and cause drag. To overcome this energy-absorbing drag, a stator is fitted between the turbine and impeller. The shape of its blades redirects the oil flow, shown here by the orange arrow. When the engine is started, the impeller directs the oil into the turbine's blades. Due to the one-way freewheel, the stator remains static, and its blades redirect the oil from the turbine into the impeller in the direction of rotation, indicated firstly by the oil in the tube and then by the graphic. This action is known as the torque conversion phase and is followed by the turbine accelerating to provide the input drive for the transmission. When the turbine speed approaches that of the impeller, the oil hits the opposite side of the stator's blades, causing it to start rotating on its freewheel. At this point, the freewheel can no longer redirect the oil and thus becomes ineffective. This is known as the coupling phase. Inevitably, there's always a slight difference in speed between the impeller and turbine. To eliminate this slip, the converter is fitted with a clutch that mechanically connects the turbine and impeller together at the appropriate time. This is known as the lock-up phase. The transmission's oil pump is located behind the converter, and it supplies the oil pressure for the hydraulic circuits. The cycloid pump is driven by the engine via the torque converter's impeller. The pump receives its oil via a strainer, and the oil is cooled by a water heat exchanger. The quantity of oil flowing through the heat exchanger is regulated by the control unit via a temperature-dependent flow electrovalve. In addition, situated behind the valve body is a thermostatic valve operated by a bimetallic spring. It controls the flow of oil back to the sump, to ensure sufficient oil is maintained around the valve body. The heart of the AL4 automatic transmission lies in the Simpson-type epicyclic gear train. It features two epicyclic gear trains connected together to provide the gear ratios. Two clutches driven by the converter's turbine operate one or more of the gear train's components. The clutches are of a multiplate type and are engaged by a hydraulic piston and released by internal return springs. In addition to the clutches, there are also three brakes which lock various components of the gear train. One brake is of a multiplate type and its outer plates are secured by the transmission case. The other two brakes are of a conventional double wraparound band type. They are secured at one end by a fixed pin and at the other end are connected to an operating piston. The hydraulic valve body is the component which distributes the hydraulic oil to the different brakes and clutches. It contains the various slide valves that are opened and closed to direct oil pressure into the numerous drillings. One of the valves is manually operated by being linked to the selector lever cable. The remaining valves are either fluid operated or are electro-hydraulic, worked by solenoids. In total, there are 8 electro valves in the valve body, all of which are controlled by the ECU. In addition, the auxiliary housing contains 3 hydraulic valves to control the torque converter's lockup clutch. The transmission's output drive from the planetary gear train is made via a reduction gear, which in turn makes the connection with a conventional differential. And the differential itself incorporates special seals to allow removal of the drive shafts without loss of oil. The output shaft incorporates a parking mechanism. A locking pawl engages with the special gear when the selector is moved into park. This mechanically locks the output shaft and differential, thereby preventing the vehicle from moving. The AL4 automatic transmission's gear changes are electronically controlled by an ECU, which in turn operates the electro valves and regulators in the valve body. To operate, the ECU requires input signals from a variety of sensors, including throttle position from a potentiometer plus a kickdown switch in the cable, engine speed from a crankshaft sensor, gearbox input speed supplied by a sensor close to the turbine shaft, vehicle speed provided by a sensor opposite to the parking gear, and oil temperature from a sensor located here. There is also a multifunction switch that communicates the position of the selector lever. And a switch on the brake pedal informs the ECU when it has been depressed. The two main signals required by the ECU to determine the gear changes are position of the accelerator and the vehicle speed. In response, the control unit operates an electromodulating valve to generate a variable operating pressure of 0 to 3 bar. The pressure is directed to a regulating valve, which controls the so-called line pressure to between 3 and 21 bar. It's represented by the orange line on this graphic. A sensor is used to continually monitor this pressure. The line pressure is then directed, via the electrovalves, to the clutches and brakes, which are operated at the appropriate times. To improve driving comfort during gear changes, the oil pressure to the clutches and brakes is applied progressively through a flow damper, seen here. It's also represented here on the graphic. The ECU also controls the operation of the torque converter's lockup clutch. This is achieved by the ECU operating a second electrically operated modulating valve to provide a pressure of 0 to 3 bar. The pressure is then directed to the valves in the auxiliary housing, which in turn issue the lockup command for the clutch. The AL4 automatic transmission is able to adapt itself to the driver's style of driving and the road conditions, and can operate in 3 completely different modes. The standard mode is selected by default whenever the engine is started. In this mode, the control unit can select from 9 auto-adaptive gear change programs ranging from highly economical to sporty. Depending upon the driving style and the road conditions, the electronics choose the most suitable program for the current situation. To select alternative driving modes, 3 switches are provided on the center console. S selects the Sport program, which provides the best engine performance for the enthusiastic driver, but of course to the detriment of fuel consumption. Snow mode should be selected when moving off on a slippery surface. When the lever is in position D, it reduces wheel torque by starting off in a higher gear. For descending steep gradients, move the selector to position 2 and press button 1. This engages and holds first gear for maximum engine braking. The AL4 automatic transmission is lubricated for life, the only requirement being to check the oil and top it up if necessary at 60,000 kilometer intervals. The recommended oil is the same as that specified for the 4HP20 transmission. Incidentally, the oil level is checked by removing the center bolt from the drain plug. And you'll find the transmission's oil filler plug near to the selector cable. By utilizing the latest technology, Citroën have produced an automatic transmission which not only makes driving more pleasurable, it's economical and highly efficient too.